EMINENCE has been designing and manufacturing custom loudspeakers and high-frequency devices for OEM customers since 1966. Our engineers work closely with our customers' product development teams to build high-performance audio products for many of the industry's leading brands and have built a reputation for high quality at a fair price. Hello, my name is Tom James and I'm the product design manager here at EMINENCE Speaker. I've been at this workplace for 23 years. We have a department that consists of a couple of lab technicians, 2 design engineers, a CAD tech, and a customer service representative. We handle all the custom designs and catalog designs for EMINENCE product here. And hang with me here and we'll walk you through the department so you can see what we do. Here in the design lab, we put together the original engineering samples based upon the customer specifications and sometimes through a competitor's driver that's been provided. The samples are assembled and then there's some drying time and then we move on to the testing segment of the process. Here in the lab we measure each engineering sample with computerized test equipment. We compare the quantified data with the customer's request and then submit the data to see if an additional sample iteration is required in the process. Using a non-contact laser, we quantify the high power characteristics of a loudspeaker and can compare those to those modeled in our design engineering software. High frequency devices are modeled using acoustic simulation software. The geometries of those devices can then be transferred to 3D CAD software for production of tooling and other related parts. Once the computer-aided drawings are generated for a particular model, complex shapes can then be realized here using an in-house rapid prototype machine. In a joint venture with a software manufacturer, we offer EMINENCE Designer, a software program for basically designing the low-frequency component of a system. Our design efforts cover a diverse range of products. Beyond woofers, tweeters, and high-frequency horns, we are in the process of bringing a totally new passive speaker protection device to market called Defend. The final step in the design process is to validate the design, to find the maximum power handling of each speaker. Every transducer is subjected to a high-power simulated music spectrum until it breaks.
I've worked here 18 years. I am the supervisor on the compression driver line. We have 11 employees in this department. All of our compression drivers use titanium. Here we start with a roll of titanium and our blanking press. Next we use heat station to start our forming process. This is our final step in forming our titanium diaphragms. Just like we do for loudspeakers, we also wind our own voice coils for compression drivers. After a quick baking process, we dress the voice coil and iron the tinsel leads. Here we assemble the voice coil and titanium diaphragm together, and then goes through another quick baking process. The assembly then goes on a locator ring. Here is where we assemble the magnetic motor. We start with the back plate, the magnet, and we finish with the top plate. We install a phasing plug cut to size, then we assemble the diaphragm and cap. For the final step, we use 3 screws to assemble the cap and diaphragm. Then we solder leads. After the driver is magnetized, we perform a series of quality control tests. Then each driver is packed for distribution. Gambrell. I am the supervisor in the voice coil department. I have been with the company for 16 plus years. I currently have 17 employees working under me. At Eminence, we manufacture many sizes of voice coils, ranging from 1 inch to 4 inch. The first step in making a coil is the winding process. It involves wrapping wire and a former material on a mandrel to keep it round during the entire process. We use copper and copper-clad aluminum wire in various sizes. We use Kapton, Nomex, and paper former materials. We bake the coil next to cure the adhesive used for coating the wire. This machine is used to remove the mandrel as it is no longer needed. It is called the punch-out. With this machine, we then apply an assurance bead of glue on the top and the bottom of the winding. We have recently added ovens and ventilation, which allows us to batch bake our coils. This double baking process adds quality and reliability to our voice coils. For added strength, we add beryllium or copper strips to many of our coils, which also requires a wire cleaning process. Next, we apply a paper or tufken collar to protect the wire that goes from the winding to the tinsel leads. This is called an auto splice machine, where we add tinsel lead to finish the coil. The final step is our quality inspection. This is where we check the DC resistance and overall quality of the coil.
My name is Garrett Gambrell. I'm supervisor over the press room and paint line. I've been here 2.5 years and currently have 14 employees. We run a variety of baskets here, 2 styles, one being cast aluminum, ranging from 10 inch to 18 inch, the other being stamped steel, 6.5 inch to 15 inch. We also have a variety of cores, 2 styles, powdered metal and steel, ranging from 1 inch to over 4 inches, and vented and solid. Now our solid cores, we weld to a back plate, and our vented cores, we stake to the back plates. We run a top plate here that we also weld to a basket, and in the case of aluminum cast baskets, we stake using drive screws a top plate to the basket. All of this is done prior to paint. We run a variety of size of plates, 3 600 inches all the way to 7.5. We make all those in-house on our 2 blanking presses. Now let me show you a little bit how we do that. We have one 300-ton mechanical blanking press here. We blank our top plates and back plates there, ranging from 3 600 to 5 3/4 inch plates. We also have a 600-ton hydraulic press that also blanks our top and back plates that are 7 inch and 7.5 inch. We have 2 300-ton mechanical coining presses. When we coin a plate, we are removing a burr from the OD of the plate, as well as getting the plate flat within our tolerances. We also make our own terminal boards in-house. We blank our lugs on one machine and assemble the boards on another. Once our parts are either welded or staked together, they go through our electrostatic or E-coat paint process. Here we have a monorail system with each rack capable of holding 12 parts. They go through a series of wash tanks, our paint bath, a final rinse, and a series of ovens to cure the paint. They are later removed from the line and staged for final assembly.
My name is Jason Stanley. I'm the production manager here at Eminence Speaker. I've worked here for 18 years. I'm going to walk you through the final production area and the packaging department, which employ 35 people. The first step of the round table is taking the basket and top plate and attaching a terminal to the basket. There are 2 methods of attaching the terminal. One is a glue-on and a rivet. Then we put the basket top plate on a centering gauge and can apply an optional rear gasket. In this area, this is where we assemble the magnet, core, and backplate with a glue and activator. This machine is a vacuum to remove debris from the magnetic gap. This station is where we insert a mylar gauge into the coil to set the height and apply a bead of glue to attach the spider. At this station, we apply a bead of glue to the foot of the spider. As we install it into the speaker, it's attached to the coil and the basket. At this station, we apply a magnet ID label, set the cone, and then press it so the surround is attached to the basket. At this station, we apply a bead of glue to attach the cone, spider, and coil. Then we put it into the spray booth to accelerate the curing of the glue. At this station, he threads the leads through the cone and the terminal. At this point, we can remove the mylar shim and dress the leads. Next, we apply an edge treatment. On cloth surrounds, it seals the edge, and on full paper cones, as in a guitar speaker, it would change the tonality. This machine applies a bead of glue to install the dust cap, along with a bead of glue to prevent metal buzzing. After the dust cap is installed, we send a speaker through our C-core magnetizer. The next station is where we install and press our front gaskets. Our last process on the final assembly line is where we crimp the tinsel to the terminal. Then we snip the excess tinsel lead and dot the terminal. At the end of the production line, there is an oven to help dry the glue on the speakers so we can test every speaker that we make. Many of the speakers we make require a magnet boot and a backplate label. Most of the products that we manufacture for distribution are single packed on our box line.
I'm Glenn Simpson. I've been here nearly 25 years. I am in charge of incoming QC, outgoing QA, our returns department, our U.S. distribution warehouse, as well as our packing department. This is around 17 people. Eminence Speaker is an ISO 9001-2008 certified company, ensuring all products and services consistently conform to our highest quality standards. We dimensionally check a sampling of each shipment of cones we receive. OD trim, height, apex dips are all examples of dimensions on our prints. But we also check resonance readings of the cone in free air. This doesn't always match what is on print for a completed driver, but in QC we are looking for consistency as much as anything. If we feel the cone is way off, we will get with a lab to build a test speaker. We also check a sampling of the received spiders. Mainly a means of R&D, the true machine checks deflection of the spiders. We save this compliance data but are mainly interested in deflection readings, which is the amount of movement a spider makes under a given amount of force or weight. We also do occasional checks on metal parts, but the true heart and soul of the speaker is the cone. Whenever we have engineered a new spec, we place it on retest for a while to make sure it won't be problematic. Retest is just what the name suggests. We are again sweeping the speaker as we do at the end of the production line, but we now have let the driver set for at least 8 hours, so all of the glue joints and treatments are nearly fully cured, or at least on their way. Some customers actually require us to check their product again after it is dried.
In some instances, we are also asked to check frequency response, which we do on either our NTI system or our Clio system. Once through retest and frequency response testing, the speakers are ready to be packaged and shipped.